all, this is Harni. Welcome back to the YouTube channel Code with Harni. Today we are going to solve LeetCode day 17th challenge. Find the maximum length of valid subsequence 2. Yesterday we solved maximum length of valid subsequence 1. So yesterday they have given it is same as like yesterday's question. So if you want to try to solve today's question, it would be better if you would have solved yesterday's question to get the basic idea. I highly recommend you guys to go and watch or solve the yesterday's question to get a better idea of how we are going to solve today. Okay, so the same as yesterday, they will be giving us an integer array nums and a positive integer k. Okay, yesterday they won't give us any, they'll be giving us only num, there is no k. So we'll be doing mod of 2 and adding those two consecutive elements in the subsequent array should have the same mod value, right? When you are doing the mod 2 today, instead of mod 2 we will be doing mod of k, and the mod across adding consecutive elements and doing mod should be same throughout the subsequences array. Now just take a look at this example. Yesterday you will be doing mod 2, today we'll be doing mod k. So 1 plus 2 mod is 3, mod 2 is 1, 2 plus 3 is 5, mod 2 is 1. So like this, all this contributes same parity 1 1 1 1. So here the parity can be 0 1. So here the parity can be 0 1 2 because k equals to 3. So it varies till the length. They have told 1000, so the parity can be from 0 to 999. So you have to keep on checking what is the difference. Here they have given k equals to 3, so here 1 plus 4 is 5, 5 more 3 is 2, right? So then which element can contribute? Again 1 plus plus 2 3, if you take 4 plus 2 is 6, 6 more 3 is 0, so this element you can't take. 3 plus 4 is 7, 7 more 3 gives us 1. So for 1 plus 4 is 5. Okay, that gives same mod as the previous two consecutive. So this we'll remove 2 and 3, we'll take 1, again 4, 1 plus 4 is 5, which contributes to the same mod 2. So which gives us the longest valid subsequences. So let's take this example. So what is that example states? 1 4 2 3 1 4, right? So this is 5, and again if you take this as 5, then this contributes to 5. So this in turn contributes to the length of 4. Okay, so let's see another valid in this itself. So if you don't take 4, 1 plus 2 is 3, so the length 2. So the same 1 3 is 4, which contributes to the length 2. This is mod 1, this is mod, the resultant mod will be, answer will be 0, this is mod 1, here 5 mod 3 equals to mod 2. So if you see, for k equals to 3, we'll have 0 1 2 like this until k mods. So 0 corresponds to 1 valid length of 2, so 1 corresponds to the length of 2, and 2 mod corresponds to the length of 4. So among this we are returning the maximum. So there is no way that we have to calculate all the possible mods, correct? So let's assume another case here. If I take the same example as above, 1 4, let me take this example. So if I take this example, 1 plus 4 is 5, 1 plus 4 is 5, but 1 plus 5 is 6, right? So say 5, 6, 5 plus 4 is 9, 4 plus 8 is 12, and 15. So which can contribute maximum length? Either it can be 1 4 1 of mod, it will be mod 2 here, mod 0 has 1 5 4 8 7, right? Because 1 plus 5 mod 3 is 0, mod 9 mod 3 is 0, 12 mod 3 is 0, which is this is mod, or mod gives 0, which is gives us length 5, this is length 4. Okay, so now how here if you see 1 mod 3 gives us 0, sorry 1, 4 mod 3 gives us 1 1. So if you see all the mod is having same value, here if you see here everything contributes 1 1 1. So 1, so x mod 3, 1 mod 3 equals to 1, 5 mod 3 contributes 2, then 1, 4 mod 3 gives 1, 8 mod 3 contributes 2, 7 mod 3 contributes 1. So if you notice one thing, either all the odd index should have the same mod and even index should have the same mod, so that is a valid sequences which that can be a valid sequences, or all the integer, that's a basic, either let's assume this is x and this is y, all the x should have the same mod, okay, all the y should have the same mod. So together if you add, okay, which can contribute to whatever mod k equals to, right? If you see now 1 plus 2 forms 3, again 2 plus 1 forms 3, again 1 plus 2 forms 3. So the basically all the odd index should have the same mod, all the even indexes should have same mod. So the same it can be if k equals to it can be either 1 3 1 3 1 3 1 3 like this. So so because 1 3 will be giving us 4, the same 4 it can be, the same 4 it can be. So all the after adding, if you do modulo operation between two any consecutive elements, it will have the same mod, because all the because we are going to do odd plus even, odd plus even next we are going to add like this only, right? Two consecutive elements. So if these mods are equal, okay, then obviously with this uh, well, if you add anything, uh, if you add previous or next, if the previous or next mode of 5 are equal, which means if you add this or this will give us the same. So what should be the next? This should be same as equals to the previous of this, right? So that's what all the odd indices should have the same mode, all the even indices should have the same mode, which means it will form a valid subsequence. So now how we will form this? So we know to the max we are going to do the mod of 3. So we want only if you do mod of any number, you will get either 0 1 2, which is something less than or equals to k, because we are doing the mod. So what we are going to do is we are going the just as simple as that. So you will be going to take a DPRA, okay. For example, k equals to 3. So 0 1 2 0 1 2 Okay, now if we just see, okay, now we'll be traversing through nums. For num and nums, what we are going to do, we'll be going to do num of mod or equals to k, so that we will be getting either what is the current mod for that number. Okay, once we get the number, this is what you're getting. Let's assume for this 4 can come for 2 as well, it can go for 1 as well. So you have to traverse through all the previous mods. So previous in range, let's have k. Okay, so if it is k, I have shown you here itself, right? This one can go for 2 previous or 1 previous. So it will range, previous will range from 0, 1, 2, right? So now what we are going to do, now we are going to have the DP of, now we are going to put previous of num equals to, now we are going to store, for let's assume previous is 1, num is, for this number previous is 1, and the num is also, because we have did mod, the num also will be 1. So 1 of 1 will be 1. Okay, the previous will be 1 of 2, right? So this we would have stored it somewhere, right? So 1 of 2 plus 1, but for this we are going to add it 2 of 1. Now we are going to add, like, because it's always swapping. If you see 1 2 1 2, so to get to store 2 of 1 means, now the 2, the number is 1, 4 mod 3 will be giving 1. What our answer would be? These answer we would have stored a DP of 1 of 2, right? So plus 1. So that, which means num of previous of num, to store 2 of 1, we are going to store 1 of 2, plus now I'm going to append this as well. Okay, so that's what, so DP of num of previous plus 1. So again, if you see for previous of now when 1 comes, so if you see when previous equals to 1 of 1 would have came, again we would have stored 1 of 1 already plus 1. So among this, whatever the maximum comes, whenever you are calculating max subsequence, we will be getting is max of max subsequence, comma, dp of previous of num meter. So we have to return the max subsequence. So I hope how come this work, because anyway we need only odd and even, odd, all the odd indexes should be same and even should be same. So for every time, for let's now I hope how this condition I have put. So for example, if 1 of 1 means we would have stored 1 of 1 plus 1. So for this particular 4 we have two cases. Previous can be 1, so that maximum subsequence would have updated to 1 of 1 to so if you see 1 of 1 would have already have 1, because plus 1, when it is 1 itself it would have got updated to 1. Okay, so now 4 comes. So if you see 4, already we have that mod. Now the number is Now let's take the number as 4. 4 mod 3 equals to 1. So now previous will be 0 comma 1. Now 0 comma 0 will be 0. So now I'm just considering 4 as my first thing. So 0 of 1 will be, for now, will be 1. Okay, now because I'm considering this is the 0 element for the first time, I'm going to consider 4 as my first, okay, element. Now then 1 comma num is 1. Okay, we will be checking previous 1 comma 1. Previous 1 comma 1 has already has 1, right? Now previous 1 comma 1 is already has 1. Now we are going to update this 1 comma 1 with plus 1, which means now this will get updated to 2. Now the maximum subsequences will be having 2. Already 2 would be there for 1 comma 5. So like this it will go. Now for example, if the 5, this 4, for this 4, what we will be for, this is 1. So now our previous will be 2, num is 1, right? Previous is 2, num is 1. For this we should calculate 1 of 2 plus 1. So now this will get updated to, already the 1 of 2 will give you 2, plus 2 of 1 will give us 3. Understood? So now 2 of 1 will be 3. Now again for this 2, when it comes, okay, previous will be 1 and num will be, mod will be 2. Now after 8 mod 3, if you do, you would have got 2, right? So 1 of 2 I want. For that, what will I check? Previous will be 2 of 1 I would have calculated and kept, right? So with that, now I am going to update 1 of 2 with 4. So like this, we'll be keep on swapping the indices and updating, so that we'll be having odd even indices should be same. I hope how this works. So this 4 will be coming. So next when 7 comes, 1 of 2 is already, when previous is coming as a 2 and 7 mod 3 would have got as a 1, right? So 2 1 will come. Miss 1 of dp. Now if you swap dp of 1 of 2 plus 1 is 4. So again 2 of 1 will get updated with. Now we have got updated to 5. So the maximum subsequence would have got updated to 5 and we will be returning that 5. I hope how this works. Initially all these things will be 0. So I didn't traverse each and everything. I just traversed with the, what is the valid subsequences and how the previous and num will be doing. Obviously previous will be navigating to 1 2 3, but I'm just taking at which particular index the values will change. Okay, and how this swapping works, that also I explained. I hope that also will make sense to you guys, how this 4 will get updated to 1, and for this how this count of 4 would have got updated to 3. All this I have explained. I hope this makes sense. Now the time complexity for this is, we are traversing num n and we are traversing k times for every time, right? And space complexity would be k square because we are taking modulo of everything. So there is no point we need to store the n range, because we are anyway going to do modulo, and we just need modulo values to find whether it's a valid subsequences or not. So yeah, that's all. I hope this make sense. This is the same exact solution I have solved. Just take a look at this example. We are storing a DP of array of k into k values, because num can, if you are doing mod, it num can be go for 0 1 2 to the max k. So that's why we want the k, and we'll be for that particular num, previous can be anything 0 1 2 till the range of k. So in that we'll be checking previous of that num, and have, for example, if our previous is 2 1, what valid indexes will form 1 2, right? So that's what. So now we'll be checking our previous is 2 and current modulo operation, for example, if it's 1, the previous valid subsequences should have formed with 2 1. So with that, I'm taking this into account. So among that, what is the valid subsequence maximum valid subsequences? I'm just thinking and returning that, and yeah, this works. I hope you guys would have understood the explanation why we are doing this, how this condition works, all this I have explained. If you need further explanation or anything that was unclear, please do leave a feedback so that I can explain or improve myself better for the upcoming videos. If you do like my video, please do like, share and subscribe, and share it with your friends. That will keep me motivated to do videos daily. Yeah, thanks for watching.